Hello, everybody, and welcome to my presentations. So, first of all, I am very thankful to the organizer of this forum, 2020 Chongqing International Forum on New Generation Information and Communications, for inviting me. And I'm gonna present this topic to you, that is trends and issues in artificial intelligence driven Internet of Things, or AIoT. So I'm a professor in computer science and engineering department here at Sejong University, South Korea. So last year I had an opportunity to visit Chongqing, but this year because of COVID-19, we are giving the talk virtually. But I believe that you would enjoy these whole presentations. So let's see that what topics we are going to discuss, today. So that is, first of all, I like to give some idea on what we actually mean by AI-based IoT and its, the data analytics part. And after that, I like to, discuss something on wireless perspectives in AIoT, and followed by the discussions on AI in IoT security, and also what are some of the emerging concepts or issues, and then we can have a summarizations of research directions. So when comes this motivational aspects, you see that here this is the technologies, this IoT, AI, and machine learning, and edge computings. So these are the technologies that are currently being used in different kinds of application, service, or whatever we say. So mostly we see that AI and machine learning and IoT is kind of head to head, or in another word, the most parts of current technologies are based on IoT and AI machine learning. And that's the reason the blending of these two has some meaning. So also if we look about these investment aspects, so investment on AI and machine learning is also comparable to IoT. So a few years back, the investment on IoT was larger compared to AI and machine learning, but now companies are focusing more on AI and machine learning. So the integration of these two, basically, we can say that is dominating, parts in investment, aspects. And in fact, if we even see some survey or statistics, some times back, IBM Institute, they're conducting a survey where 19% of C-suite executives, they showed their interest, that they are highly keen, for getting the benefits of augmented IoT with AI. So that's why these 19% C-suite executives, we can give the terms as reinventors. If you see this simple graphical representations in this vertical axis, then let's say this is kind of indications that transformation for the vision of intelligent IoT. And in this axis, there's a horizontal axis, that is, let's say, the level of the IoT adoption. So the both that IoT adoptions level would be high, and the intelligent vision transformations should also high. So that is here that we say there's 19% of reinventors. And obviously the mostly still are observers when it considers both of the IoT adoptions and the intelligence IoT vision. Nevertheless, we believe that see, these tacticians are 31%. When this tactician joins with the reinventors, then again we can say that there are enough motivations that why we all should take care of this gradual investment, or technology deployments, or the adoptions of this whole AI and IoT based technologies, in addition to our other uh, technology paradigms. Okay, so we have the motivations. Now let's think about that, where this, how AI meets IoT. In fact, the IoT, both IoT and AI is coming from several decades. But recently, because of the miniaturization of the devices and some computation advancements, the IoT, takes, roles to emerge as a very separate entity and paradigm. But uh, the AI and IoT now newly we are thinking to have the integrated forms, and they meet exactly here in these steps, this analysis steps. As we all know that sensors, first of all it creates the data, and this data communicated over the networks, and the aggregated or integrated informations are analyzed in the analytical analysis phase or for the augmented intelligence. And based on that augmented intelligence we do some act. So ultimately this act very much depends on this analysis phase. And even sometimes this analysis and the act they are kind of dependent on each others, kind of in a feedback manner. So this is where the AI particularly plays immense role. So what are the benefits of this AI based IoT? So definitely we will be coming across more benefits, and it will be clear more as we go forward in our presentations. But to sum up the just a little bit of that, I would say that let's see this one, this enhanced operational efficiency. As you know that AI can detect the pattern as it works on the stream of IoT data. So definitely because it can uh, uncover the pattern, so we can say the operational efficiency for anything, for a company perspectives or a service perspectives, consumer perspectives, the whole bounds of operational efficiency can be boosted up. We also can achieve some better risks management. For examples, that when we can forecast a broad range of risk, and so that we can automate the response also. We can come up with new products and services, because that these days natural language processing is becoming more feasible, and that basically allows people to communicate with their devices more flexibly, and I can say that in a better way. And if it is so, and that's the our thing, that because people are being communicated with the device more conveniently, so that's why their behavior will be changed, and that things can be translated into new products and services. We can also have increased IoT scalability. IoT itself, just by reporting some sorts of event and sensing some sort of thing is not sufficient enough. The real benefits will become that when we take the advantage of the analytics phase, and at the time that when we summarizes the data from one device to another, so definitely the scalability become increased, because every device doesn't need to decide the things itself. Also, as you see, the device downtime or business downtime, we can predict in advance based on our AIoT based analytics, and that causes that our overall unplanned downtime will be less. And last but definitely not the least is technology convergence. We are always keen to see the convergence of the technologies from long back, and these times when AI and IoT will be merged together, and they can consider each other. So definitely the convergence will be one step ahead. So if we see the use cases of AIoT, or from data analytics perspectives, so definitely we'll be coming across a bunch of important aspects or important fields. As I said that predictive maintenance, and in current market, this basically you see the very high 24% is all about predictive maintenance. Then we might have quality inspections or assurance. when we develop a product, we go to the production steps. The quality inspection is a very vital. So AIoT can play a significant role over that. Also we can achieve process optimizations in manufacturing um, industries. We can have better supply chain management. We can have better cyber security and privacy. We can have even we can detect, we can do the surveillance, right, to check the physical movements or physical security that stops. And overall the resource optimizations can also be better achieved if we adopt AI based analytics. We might have data management can be more automated. We might have smart assistants, and definitely even though the research community is less, but AI can be equally utilized in research and development. And and the recent example is COVID-19, where we saw that we can collect a large bunch of data from different people's devices and their activities and the movements, and that things can be analyzed by using our AI for our research purposes. So ultimately in in our everyday lives, when you think about an as a smart city perspectives, we can see that AI can be useful in very much in every aspect in a smart city. Ultimately smart city deals with every aspects of technologies, uh, advanced technologies. For example, so think about this smart energy, where we do lots of time series data analysis. So based on that, we can have different kind of energy applications. We can monitor smart leaking. Even we can have better insights about renewable energy resources. So those things. And the mobility is another great aspect of a smart city, where intelligent transportation systems, kind of autonomous car, traffic control, public transportations, these all things can be backed up by AI. And definitely so a smart city means our citizens also smart. And at the time, the environmental monitoring, crime monitoring, and social health that on can be you know taken together by applying AI. And definitely governments or even the city, they can also have their own long-term decisions to make the future city. So when they design the city for the future perspectives, they can collect lots of IoT and sensor data, that which part and where the decisions can be you know can be manufactured and can be designed in a different way based on the insights that we obtain from AI. And ultimately, a smart city is all about the handling heterogeneous data characteristics. So when we see the data analytics perspectives, so this data analytics can be classified into this kind of major categories: descriptive analytics, predictive analytics, prospective analytics, and adaptive analytics. Descriptive analytics is kind of summarizes the raw data. So we can say that, let's say, data aggregations, data summarization, that things. And predictive analytics, they rely on historical data, and then utilize this historical data for advanced they use advanced machine learning or statistical techniques to model this historical data, and they predict something. And prospective analytics, they not only predict the stops, they also suggest what to do in a particular events happen. So we can say the prospective analysis kind of combinations of both descriptive analysis and predictive analytics. And adaptive analytics is that what we obtain from perspective analytics that can be adjusted by using the real-time data. So let's say we see something on application specific IoT data analytics. So you all know that healthcare is one of the very central area that where the AI, it can really play a huge role. So there we have the patient's health data and data analytics systems. So these together, so they can provide lots of actionable insights. And this system perspective can be translated into clinical grade as well, where constantly monitoring physiological status from the different sensors can be processed in the cloud, and then the analyzed data can be given to the caregivers for prognosis and some other sort of actions. So these healthcare settings is one of the key fields, but equally this data analytics can be used for ITS, smart farming, smart energy, that I gave a brief idea. So if we see a framework perspectives, let's say this one, the similar framework perspectives can be done for ITS, farming, or smart energy, but here this framework is particularly for smart healthcare. Even recently we used sorts of frameworks for our recent works, where we combined lots of health data and the data from the different kinds of social network services, and then we applied machine learning stuffs and different sorts of analytics, and then we found some various kinds of uh, insights that can be used. So here in this framework, if you see that here is zone one. In the zone one, basically it's kind of data collection phases. The data sources, the health record as a fog computer or social networks or applications, and then you have this integration sites. And in zone 2, it's all about kind of cloud, cloud side. And there we have the scopes of applying machine learnings and analytics, where we can use R based, TensorFlow based, or whatever. Even we can use various other kinds of data analytics tools, or kind of map reduce, or scripting, so those things. So it's kind of a very multi perspective analytical zone or platforms. So after that, we present the data in output formats, perhaps for other business intelligence, or maybe to some mobile app for the consumers, or maybe it can be sent, the result can be sent to the notification hub, and so on. So here, I am, showing you a tabular representations that how, machine learning algorithms, can be used for data analytics for different kinds of IoT applications. You see the classification and clustering that can be used for smart traffic, optimizations, and there we can, optimize the traffic predictions, that how much traffic will be there at a particular time in stand. Think about the other example, for example, support vector or regressions. So that can be used for smart weather predictions. So similarly, another things perhaps this is very another one is principal component analysis that can be used for monitoring public places. And the metric that we can optimize here is fault detections. So I'm not going to details into these tables, but here these tables actually says that classification, clustering, linear regressions, k-mean, naive-bayes, knn, and random forest, and or whatnot. Different kinds of machine learning algorithms have been investigated for different kinds of IoT and smart city use cases, where we can have different kinds of optimizations. So it's very useful. That's why now I my background is wireless communications. So from that perspectives, the machine learnings or AI can be greatly used. And for the last couple of years, lots of research has been done. And that when comes the wireless, mostly the very first things that come into our minds is physical layer things. And in physical layer things is all about the uncertainty associated with the channels. And and because of that uncertainty of the channel and several others service requirements, depending on the service types. For example, let's think about that intelligent construction sites, and there perhaps we can use this kind of communications infrastructures, where the typical data rate might be this, and maybe we can have maybe 30-minute delay or 10-second delay, or maybe few seconds delay. And the energy source might be battery power, or maybe main power. So whatever it is, sometimes energy resource must be energy harvesting. So this also imposes some other kinds of uncertainty, that what amount of data rate we can achieve from particular communication systems. So that's why we need to control the data rate. So for adaptive rate controlling, for adaptive rate controlling, that we see that various kinds of machine learning algorithms have been used. For example, this reinforcement learning, KNN, or SVR, this kind of things. And you know that when we think about communications, definitely the another great resource is spectrum. So spectrum sharing, spectrum management, spectrum scarcity, to deal that kind of things, we have various kind of assignment managements and cognitive techniques. So there we also can use AI or machine learning approaches, for example, in vision learning, or deep convolution neural networks, and that become that are found useful. Similarly, we can also sometimes try to improve the channel conditions, or improve the data receptions. So we can use the channel decoder or channel equalizations. Here we also can use different kinds of machine learning stuff. So also that when we particularly focus on the signal arrival in beamforming perspectives, and then we can see the direction of arrival or adaptive beamformings for to have that improved DOA estimations or adaptive beamforming, we can apply again different kinds of machine learning algorithms. So that might be ANN algorithms or radial bias function neural networks. So that things. So, in a nutshell, this for wireless communications, even from physical layer perspectives, we can use AI a lot. So, think about in a very conventional approaches that we used earlier, that adaptive modulation encoding. So here, that kind of modulation classifications, even recently we used in different kinds of machine learning algorithms, that using deep neural networks, or long short-term memory, or maybe reinforcement neural networks, that things. And very much they can classify PSK, that is phase shift keying, frequency shift keying, quarter amplitude modulation, that it stops. And on these things, there is a very cool papers in a survey, machine learning for wireless communications in the IoT, a comprehensive survey. So for these perspectives, they show these kinds of progress. Also, by applying machine learning stops, we can classify interferences. So by what it means is that we can classify that where the signal is coming from, the source, the transmitter source. It might be a Bluetooth transmitter or Wi-Fi transmitter, or it might be in a radar signals, or it might be a cosmological interferences, or maybe simply other kind of microwave of the signals. So these kind of classifications can be done by using different kinds of machine learning algorithms, where we need to have a very specific form of data representations. It might be FFT, or it might be IQ, or whatever. And IQ means imaginary and quadrature. FFT means fast Fourier transforms, or simply two-dimensional time frequency grid data. So now let's talk about some things on security. In IoT security, is there are lots of requirement challenges for IoT security, where we have to, from information security perspectives, we have to maintain the integrity, confidentiality, anonymity, and freshness. From functional point of view, we have to ensure interoperability, scalability, availability. From access level point of view, we have to have proper authorization and authentications. Similarly, we have the hardware limitations, software limitations. For hardware limitations, we usually don't use machine learning stuffs, but for software limitations, we might have. And for network limitations, definitely, because there are multi protocol communication, heterogeneous device media. So whatever, I will show you some aspects that how this machine learning or AI stuffs can provide us some improved information security, functional security, or access level security. So here is some a kind of typical security applications of machine learning algorithms. We very much are aware of this kind of classifications of machine learning. Machine learning has basically basic machine learning or deep learning, basic supervised learning, unsupervised learning, and semi-supervised learning. So now see that, for example, so let's think about the supervised learning. Let's say regression. Earlier, the supervised learning regression stops, was used for predictions, for example, weather forecasting. Similarly, supervised learning lets a classification approach we used for diagnosis purposes that a particular tissue is malignant or non-malignant. And these things now can be translated for security aspects, like thus predictions of weather forecastings can be equally think of that attacks detections, that is there, that how much attack we can predict or not, or simply this is a for classification perspective, that is a legitimate user or kind of illegal or intruder. And of course this similar kind of analytical things we can do. For examples, let's think about uh, gaming, for example, alpha zero go or network optimizations. We used to use AI and machine learning stuffs, but now we can use this kind of things to analyze and detect malware spoofing things. So this is how we can use the AI stuffs in IoT security. To be exact, here I have some sort of kind of descriptive stuffs. Let's think about that. Security authentication access control is really a great things, and the resources have shown that recurrent neural networks outperforms usual machine learning and deep learning, whereas LSTM, that is long short-term memory, that outperforms SVM. I mean, as far as authentication access control is concerned. But DL, that is deep learning, is usually much better than machine learning algorithms. When comes this attack detection and mitigations, we see this kind of things. This extreme learning is suitable for distributed attack detections. We also found that KNN, that is k nearest neighbor, is good for small networks. But if the networks is large, at that time SVM works better. If we think about to mitigate DOS attacks, so that is denial of service attack, then we see that random forests perhaps have low number of control and model parameters, and it doesn't require any kind of feature selections. But MCA has good detection accuracy, but this is multiple correspondence analysis, and compared to this MCA, ANN, that is artificial neural network, is even better. When it comes to anomaly and intrusion detections, the k-means used for anonymizing IoT data, because the k-means doesn't need the label data, and we all know that IoT data where the label data is not available, so definitely we can use k-mean. And the decision tree is found easy to implement for these anomaly intrusion detections. Uh, However, DL shows very good performance. And when it comes to malware analysis, PCA, that is principal component analysis, that has its dimensional reductions, and it reduces the model complexity, the model we develop for malware analysis. And in perhaps good better, but usually DL are recommended compared to traditional machine learning algorithms. So there are lots of emerging topics or emerging issues that we consider when we talk about AI in IoT stuffs. For example, such a things is quality of IoT experiences. Now, quality of IoT experience is a new terminologies. So, but this is very much needed. So, what is this? Quality of IoT is basically a metric that aggregates the delivered quality of an IoT service from both human and machine perspectives. We know that quality of service things that coming more from application perspectives and service perspectives, but when comes both machines and humans together at various levels of the entire things, you know entire ecology, entire ecosystems, then we need to formulate quality of data, quality of networks, quality of context. So it's a kind of multi multi-party involvements, so where both human and machines and business entity and other stakeholders are there. So we need to come up with both of these parameters: quality of experiences, that basically coming from subjective and objective human factors, and quality of machine experience, that mostly objective performance factors. So these together, we can have quality of IoT service experiences, quality of IoT experiences. So based on this quality of IoT experiences, so many things can be redesigned actually. The precision medicine informatics, we can use AI IoT alerts. So for example, in risk minimizations, safe and secure medication, medical error minimizations, even in automated gene expression measurements. I'm not going to details to explain that. If somebody is interested, recently we published this paper, Precision Medicine Informatics, where I have explained these things in great details. Now think about some research directions. Research direction from data analytics perspectives. We have to think about that various kinds of data characteristics. The quality of data is very important, and the characteristic data sometimes good, data sometimes not good, data sometimes coming up with different characteristics. So that we need to consider. Also, what is the nature of the IoT application itself? That should role play on the IoT data characteristics and on the algorithms. So when we design an algorithms, we need to target some particular IoT data characteristics and applications. So in wireless perspectives, we all know that we have lack of signal data sets. Also, the data representation is what kind of data representation we use. It is also not decided. Also, that that what kind of learning model and architecture we can go for is still it is not perfectly answered. And when it comes to security perspectives, as we all know that let's say deep learning or DRL, these models themselves have lots of limitations, and also the training data sets and availabilities for the IoT cases also matters. And also there's another thing is that the adversarial machine learning in IoT. What that means is that intruders or the bad person, they try to exploit the weakness or the characteristics of machine learning or AI itself. So when they design their adverse algorithms, so they keep the problems or the features of IoT and both machine learning and the AI stuffs itself at the time. So for to tackle that kind of things, we need to think about from adversary perspectives. So whatever, there are another great things that is the massiveness. So hyper convergence. This AI and IoT is going towards is it started its journey, but from that perspective, so the convergence is still is a great issue. It will solve the problem AI and IoT one kind of convergence, but there are many kinds of fine tuning we need to do. And definitely whatever we do scalability we have to maintain, and still there are lots of factors that we can do research on to have the better scalability. And machine learning at the edge, that is always a challenge, because to protect this privacy and to have the anonymizations, we have to take the AI in edge perspective. So we might have the federated learning, but when we run the machine learning things in edge, so maybe some computation power and those things are less. But so we might have to have some sort of compromise between the accuracy and what kind of power and energy we need there. But whatever we do, we have to keep in mind the cost is a big matter. Now, by cost doesn't mean just money. We have to see the sustainability and ethical perspective, and environmental impact, and the human job perspectives. So that kind of things, that's all together. We should have some sort of cost analysis for the sustainable development and progress. So finally, I would say that AIoT is truly interdisciplinary, and it transforming us to a data-driven society. And dominant R&D efforts are clearly visible, and we must tackle convergence and security issues to have the benefits of Industry 4, so that we all together can head towards uh, digital economy within win-win situations. So this is all I had for this talk. So if you have any questions, and if you are interested to have any further discussions, please reach me to with this using this email address, islam.smriaz@gmail.com, and perhaps we will see in other times. So thank you everybody for listening my talk. Bye bye.